Hello, hello. All right, how's it going? Woo! Here we are, Saturday. Yeah, we're almost halfway there. This is the best event of the year. I'm so stoked to be here. I'm Lane. I am a core developer at a project called Space Mesh, and I'm really excited to be here today talking to you guys about a topic that I've been kind of deep diving on recently. It's quite a recent development in the blockchain ecosystem, and that topic is modular blockchains. I know you have heard a number of talks on this topic here the past couple days. I'm going to take a slightly different perspective, look at kind of high level what modularity is, why it's relevant in this context, and talk about implications for the application stack specifically. So let's kick off. Quick outline of where we're going. We're going to talk again about what modularity, what modularity is, why it matters. We're going to talk about modularity in the context of software specifically. We're going to do a very quick introduction looking at kind of the origins of blockchain and how we're moving towards modularity in blockchains. We're going to talk about the 4 key features that blockchains give you and how modularity fits in. We're going to look at the development of blockchain roadmaps like the Ethereum Roadmap and look at where we're going with respect to modularity. We're going to discuss the benefits and disadvantages of modularity. And then finally, we're going to conclude by talking about implications for Web3 applications, as I said. So I think it's good to start at the beginning. What is modularity? This is the best definition I saw. Hello, Ninja Turtle. Donatello, right? Woo! East Denver, folks. A modular system is one that gives more importance to parts than wholes. Parts are conceived as equivalent and hence interchangeable, cumulative, and/or recombinable. And I think that if you think about how blockchains work, about the different pieces of them that we're going to look at, you'll recognize that this definition makes a lot of sense because we do have interchangeable components in blockchain, and we're moving in this direction. Another definition is from the lens of graph theory, right? So many kind of problem spaces in computer science and in the world in general can be broken down and analyzed along the lines of graphs and networks like this. And I think a great definition of modularity is you have these sort of subsections of a graph where there's great internal kind of cohesiveness, cohesion, and so there's kind of like these modular shapes that emerge. So why do we need modularity in the first place, right? Wouldn't it be cool if everything could be monolithic and just be kind of more simple? Well, there seems to be a fundamental law of nature which dictates that in order to scale things beyond a certain point, we need specialization. Scale is a very interesting topic, right? You see it in biology, you see it in architecture. I'll show a couple examples of this in a moment. There are limits to the, how do I put it? There are limits to kind of like the size that a single cohesive system can grow to, right? So if you think about biology, you think about kind of the development of multicellular organisms, about cells and how they kind of scale into organs and into larger organisms and into communities from there. The only way that's able to happen is by specialization, right? So you have different cells that specialize in different things. You have different organs in a system that specialize. Again, this seems to be a fundamental law of nature, and I think blockchain is no different. Once you kind of start paying attention, you'll notice that modularity is everywhere. So when I first think of modularity, the first thing that comes to my mind is something kind of like this. So this is like a modular prototype of a modular phone. Google and a few other companies have released prototypes. I'm not sure if any of these have actually come to market, but I expect eventually they will. You can kind of think about some of the benefits of having a phone that works this way, right? If you care a lot about battery life, maybe you're willing to sacrifice a camera or a touch screen or, I don't know, a GPS or some other element of that device to snap in an extra battery. So it allows kind of customization. It also allows reuse, right? So if one individual component on this device fails, needs to be replaced, in modern phones, modern smartphones, you can't even replace the batteries, typically. You have to replace the entire device. It's very wasteful. So another benefit of modularity is that it means that individual components can be upgraded or swapped or replaced. Architecture is also very modular, right? So as we have developed more complex systems, more complex, architectural systems, so large buildings and large structures and large skyscrapers, things like that, it's not the case that these buildings are monolithic. There's increasingly many pieces that can be kind of individually fabricated and snapped together. Again, you have this kind of replaceability as well. And you have customizability, so you can develop these individual pieces and deploy them in a number of different ways. And if you are a software developer, this should sound very familiar because this is also how we build software, of course. So music is also modular. This is an example from a totally different space. There was a very brief period of my life where I tried composing and arranging music. I was really bad at it. But I did notice that it's a little bit like software in the sense that you have these reusable pieces, these melodies, these harmonies that can kind of be snapped together in creative ways or turned around or flipped upside down. And of course, there's a lot of patterns and a lot of math in music. I spoke a moment ago to biology. So of course, the human body, any complex organism is very modular. As I said, we have single-cell organisms that developed into multicellular organisms in a more complex biology, specialization around cells, and then over time into organs and into entire systems. And I think what's interesting about this is if you really zoom out from a kind of social lens, you can actually see, even at the level of communities, of people, of societies as well, that there's modularity there. Of course, even, so it's kind of fractal in a way, right? So the organs themselves are also modular. So the brain, of course, being the most complex organ, has many, many different pieces. And there are, of course, very interesting examples from history where people experience traumatic brain damage for one reason or another. And let's say they lose the ability to create new memories, right? Because that's a specific portion of the brain. But all the rest of the brain still functions. So that's another benefit of modularity. University curricula are also modular. I think this is kind of a cool example. Not everybody wants to learn the same thing. And as universities have developed and evolved and become more complex over the years, curricula have also become more complex. But if you think about it, you have this idea of kind of credit units or units, right? And you can kind of like snap them together in various creative ways to build a curriculum that makes sense to you or that allows you to fulfill a requirement for a particular career that you want to go into. So yeah, again, just re-emphasizing the fact that when you really look for it, modularity is everywhere. I think the best example, and I alluded to this a moment ago, is at the social level, society, right? If you've heard me talk before, you've probably heard me talk about this idea of social scalability, which was originally Nick Szabo's idea. I think it's a very interesting idea, right? It's the idea that if we want to scale our society from kind of Dunbar's number and these small tribes into these big, fantastically complex societies and institutions that we have today, things like nation states, kind of continent-wide governance, things like this, the only way to do this is to have specialization. And I think, again, this is a great example of that universal law of nature, that in order to scale things and to grow things in complexity, we need specialization. So we have different groups of people who specialize in different things, and it's about kind of cognitive burden, right? The idea is, if you flew here on an airplane, like many of us did, you don't need to understand how that airplane works. You just need to sort of trust the institutional structure that allowed that airplane to be built and serviced and operated. So that's a great example of modularity and specialization leading to modularity. So let's move into talking about software, because of course blockchains are software. How does modularity apply in software? So this is quite interesting. I actually wasn't aware of this before preparing for this talk. In the late 1960s, early 1970s, there was an event that occurred called the software crisis. Some great articles out there about it. I encourage you to look this up and study it. So this was kind of like 1968 to 1972. So what happened was, around that time, computers were getting much more complex and much more powerful than the ones that existed previously. And as a result, developers were trying to build and deploy much more complex applications to tackle much larger problems, larger databases, larger code bases, things like that. But the tools were not yet in place to build these systems in a manageable way. So for example, object-oriented programming and many of these other paradigms that we're familiar with, even modular programming, it didn't exist at that time. It emerged in the late 1960s in response to this challenge. This is a great quote from Dijkstra. Many of you will be familiar with Dijkstra if you've studied computer science. As long as there were no machines, programming was no problem at all. When we had a few weak computers, programming became a mild problem. And now that we have gigantic computers, programming has become an equally gigantic problem. I think if you replace the word computer with blockchain here, this would make just as much sense, right? So when there were no blockchains, we had no issue. The era that we've been in the past 10 years is a few weak blockchains, and programming was not particularly hard. We have Bitcoin script, we have Solidity, we have EVM, things like that. but we're rapidly moving into a world of much, much, much more complexity in what we're trying to use blockchains to achieve. And that's why we need modularity to get there. So what happened in computing? The first thing that happened was the hardware itself got modularized. These are, of course, graphics cards, graphic processing units. I'm old enough to remember the days of the 386 and 486 and Pentium computers when there were no graphics cards early on, right? All the graphics were handled by the CPU. But again, specialization. If you want to be able to run 3D applications, very compute-intensive, high frame rate, et cetera, not to mention, of course, things like proof-of-work mining algorithms, AI, big data, et cetera, you need specialized hardware to get there. And of course, in the blockchain world, we have like ASICs and FPGAs and things like that. And of course, the software and the application stack also became modularized. If you've spent time building Web 2 applications, or even earlier than that, even pre-web applications, you're probably familiar with this OSI model, right? So this is a sort of abstraction, a set of abstractions that allows application developers to focus on a single piece of the puzzle, from the kind of hardware, electricity, bits, physical layer at the very bottom, all the way up to the application layer at the top. Most of us who have built mobile applications or web applications are working primarily at the top layer, but I mentioned many times this idea of cognitive burden, right? These application models allow us to reduce the cognitive burden because we only need to think about one layer at a time. And this, as you can imagine, blockchain is going in the same direction. You'll see similar slides in a moment. If you've written software in the past 10 years, you'll be familiar with tools like NPM, right? Of course, NPM is the largest package repository in the JavaScript ecosystem. There are equivalents to this in every ecosystem, basically, in Rust and in Go and in C and in Python, et cetera, et cetera. And there are literally millions upon millions upon millions of packages or modules. Of course, different programming languages, different ecosystems use different terminology to refer to these, right? But they're published there, and you can download them and just use them, and you don't need to understand how they work internally. They just have well-defined APIs. There's, of course, challenges associated with this, with relying upon kind of untrusted code, but it's very powerful that you can snap together all these pieces very quickly and easily and build applications orders of magnitude faster than you ever could before. As the application stack has gotten more complex, what's emerged is not only individual packages and package managers, but also these frameworks, right? So again, these are JavaScript frameworks I have up here, things like Angular, React, that I'm sure you're familiar with. JavaScript is a very mature ecosystem, much more mature than blockchain. It's been around for quite a while. But the beautiful thing about these frameworks is that they abstract away a lot of the complexity, right? If you're building a front-end application, you don't need to worry so much about where the data comes from. You don't need to worry so much about passing data back and forth between client and server. These frameworks make that very easy, make presentation very easy as well. The next thing that happened in sort of the Web 2 world was the development of the cloud. So again, I'm old enough to remember building monolithic web applications in the 90s using things like CGI. Okay, CGI script is a single monolithic piece of code that runs on a server, typically a Linux server, and it does everything, right? So it handles the data, it handles the business logic, it handles absolutely everything. Over the past 20 years, we've seen the emergence of not only cloud, but also this idea of microservices built on top of it. So yeah, the kind of Web 2 infrastructure has very rapidly embraced modularity for all the reasons I talked about before. You can mix and match different things. It's much cheaper, it's much more cost effective, it's much faster to get started in developing using these tools. All right, so we've talked about modularity at large. We've talked about modularity in software. Let's zoom in now in the final portion in modularity in blockchain specifically. I'm going to leave this amazing Cointelegraph slide up here for a sec. So in the beginning, there was Bitcoin and Ethereum, and they are, of course, quite different. However, what they have in common is that they are both monolithic, right? What does that mean? It means that if you want to execute a transaction in Bitcoin or Ethereum, you don't need to touch anything else. You just spin up a node or talk to a node over RPC using something like Infuria, send a transaction. That transaction enters the mempool, is confirmed, lands on a block, and a message gets sent back to the front end over the RPC to let you know your transaction's confirmed. Pretty straightforward, right? So these blockchains do basically everything. So there are 4 primary features or functions of a blockchain. And in order to understand modularity, we need to break them down. So the first one is data availability. The second is settlement. Third is security. And the fourth is execution. So we'll briefly talk about each of these. So data availability, what is this? Well, as the name suggests, it means that the data necessary to sort of compute the current state of the blockchain, of the applications on the blockchain, are stored and accessible, basically, via some interface. But it's a little bit more complicated than that. The difference between a Web 2 database and a Web 3 kind of blockchain that offers data availability has to do with things like crypto economics, right? So we have these powerful crypto economic tools that allow us to not only offer data, but to guarantee that it's there using very strong sets of incentives, crypto economic incentives. So things like fraud proofs, punishments, data availability sampling, et cetera. So data availability includes all of that extra baggage. The next thing is settlement. I like to think of settlement as kind of like the court system, right? So it's kind of like enforcement of contracts, so to speak, both in kind of in the smart contract sense or in the legal sense of the word. Again, this includes things like fraud proofs. So basically, this is where the systems of incentives, where the punishments and rewards are finalized, are settled in the settlement layer. And of course, there's a financial component to this as well. The third is security. So security has to do with consensus. Consensus mechanisms guarantee certain things like consistency and availability, right? So these mean that the nodes in a blockchain always converge on something, right? That's liveness. And security means that, that no two honest actors ever agree about different things. And so security guarantees that we have coherence across all the actors in the network, all the nodes, and that it's very expensive to attack the network and to attack consensus. And finally, execution. Execution is the fun part. That's the application layer. That's where you get to build smart contracts and things on top of it. And basically, at the end of the day, all these other things are there to serve execution, right? Because without execution, without applications, what's the point of having a blockchain? So let's look at how the Ethereum roadmap has evolved over time. So this is what the Ethereum 2 roadmap used to look like a few years ago, right? The original idea was that there would be multiple phases and that there would be many, many shards. There's a beacon chain, there's many shards. Each of those shards has a VM, state execution is what's referred to here, using something like EWASM or potentially EVM inside of them. And they would kind of, each of them look and feel like Ethereum today. Of course, unless you've been living under a rock, you know that the Ethereum roadmap has changed very rapidly. And in particular, there's been a recognition that how do I put it? That the landscape has shifted, right? And so this comes from an article on the Ethereum Foundation blog, which you should check out. The idea is that ETH2, there is no more ETH2, effectively, right? So what's being developed now is actually just a consensus layer. And there's an execution layer that sits on top of it, and it's going to be merged in through this merge process that happens this year. The key point here is that this was the initial step towards modular blockchain, was this development of the Ethereum roadmap over the past few years. So between 2019 and 2020 is when this kind of happened. There was some initial conversation in 2019 about, well, maybe we want to simplify this ETH2 roadmap. Maybe we don't want to try to do execution. Maybe we want to just jump ahead and offer data availability and let people use things like use things like rollups on top of it. So this is a great post on the ETH Magicians forum from Vitalik from October 2020. And again, just kind of recognizing that there's a lot of stuff happening in the rollup ecosystem. You've heard about a lot of it on stage today and at this event. And so yeah, so the Ethereum roadmap has evolved in recognition of the fact that, that rollups are going to be king going forward, along with a few other uses of kind of plasma and state channels. So if ETH1 is this monolithic architecture where it offers execution, settlement, security, data availability, all in a single client, a single monolithic application, the vision for Ethereum going forward is breaking it apart into these modules, these components. So on the bottom, you have this new consensus layer, right? That's going to give you data availability, right? The shards are going to store the actual raw transaction data, the blocks, and guarantee security through proof of stake, right? Then you're going to have a layer above that, settlement. We talked about that. That's enforcement of fraud proofs and incentives using existing EVM, right? So this is the existing Ethereum chain that's going to be merged into the beacon chain. And then finally, you have execution that's being outsourced to rollups like Arbitrum. But the really cool thing is that, again, because this is modular, all these components can be snapped in and snapped out and rotated and changed. So you don't have to use Arbitrum as your execution layer. You can use any of the other rollups. You can use optimistic rollups, ZK rollups, et cetera. And on the bottom layer as well, you can also use different data availability layers. In the extreme case, you could even imagine using something like Filecoin or IPFS, or who knows, even like a centralized data storage layer like AWS or Google Cloud or something. That's very exciting. So one project that is at the forefront of this is called Celestia. I believe someone from the Celestia project was here on stage yesterday talking about it. I think it's very exciting, right? They're the ones pushing this modular blockchain hypothesis forward very aggressively. And so they're positing that the future, again, is not going to be monolithic. It's going to have this modular architecture. And Celestia is a data availability layer that's specialized on only data availability. Right? So going back to this idea of scale and modularity and specialization, the idea is if you're highly specialized and you just do one thing, if you just do data availability, you can do it much more cost effectively, much faster, much cheaper, in a much more robust way. And again, you can then outsource execution on top of that to other blockchains, to rollups, to all sorts of things. It's not that simple, right? So this is a really fun chart that I found, which shows various kind of permutations of what the modular blockchain future might look like. So of course, monolithic blockchains, that's layer one execution, layer one security, layer one data availability. That's how Ethereum works today. Rollups, we talked about that. That's where you kind of move execution off to a layer two. But there's many, many, many other takes on this and different types of architecture, validiums, volitions, multi-volitions, validiums with external data availability, et cetera, et cetera, et cetera. And the person who put this together also hypothesized the existence of things that don't actually exist yet, right? So multi-volition or this L1 with external data availability. This doesn't exist, but it's hypothetically possible. And I expect that we'll see different projects launched to kind of fill in some of these gaps and test some of these different combinations. So it's going to be very complicated for the next couple years while we kind of figure all this out. But the future is modular, so we kind of have no choice but to get our heads around this and kind of get on board with the direction we're going. So I think it'd be interesting to talk about the benefits and disadvantages of the modular blockchain architecture model, because it's mostly good, but there are always some trade-offs. Everything is a trade-off. So specialization scale, we talked about this. If you want to really scale blockchains, transaction throughput, et cetera, the only way to achieve it is in a modular fashion. Less cognitive overload. We talked about this as well. As someone who builds blockchain full node implementations for a living, I can tell you that it's an extraordinarily complicated piece of software, right? There are tens or hundreds of thousands of lines of code, maybe as many as 1 million lines of code in the extreme case. They're extraordinarily complicated applications, and by being able to break them apart so that the developers working on them can focus on specific pieces and do really, really deep dives and own particular pieces of that architecture, the software is going to get much more mature very quickly. There's a concept in software called separation of concerns. So by separating these different concerns, the ones we talked about, into modules, you get these really nice features: reusability, swappability, upgradability, parallelization, right? So you can do things like upgrading a smart contract or your business logic without necessarily needing to upgrade the entire blockchain or layer one, right? Today, you can't really do that on Ethereum without a hard fork. And parallelization is another good example. By having many rollups, for example, that share the same data availability layer, all those rollups are actually processing transactions in parallel. It makes testing easier, right? If you're a software developer, you understand that having small, clearly defined interfaces, small modules, makes it much, much, much easier to make assertions about those modules and test them in a robust way. My favorite is creativity, right? So it opens the door to not only experimentation with kind of different languages, different frameworks, right? In a monolithic blockchain, the entire stack is written in Go or Rust or something like that. In a modular world, again, you can have different pieces that are written in different ways, and you can, you'll realize that people use the modules that you create in ways you didn't expect, which is how modularity works in software. Let's look at the disadvantages. So there's a concept also in software called impedance mismatch. The extreme case here is when you're passing data back and forth between two applications using a format like XML or JSON, right? So there's some cost to translating data structures into those formats back and forth, rather than passing them around in a native kind of in-memory, in-process fashion, which you can do in a monolithic architecture. However, this is more than outweighed by the gains that we get from the other aspects of modular blockchain. I think early on, we'll see less stability, and this should be obvious, right? Because we have many different moving parts, so there's kind of like more things that can go wrong. more points of failure. But I expect that over time, all of these positive features will combine to produce much more stable blockchain infrastructure. Redundancy, things like that. This is an interesting one. It's a bit of a nuance. It makes things like defining trust relationships and governance a little more complicated. Right? And again, in the case of a modular blockchain, at the end of the day, there's only Ethereum, right? In the case of ETH1. And there's a single kind of governance process, multifaceted governance process that would cover data availability, execution, upgrades to the roadmap, et cetera. In a modular blockchain world, governance gets more complex. You have to have different governance for different pieces of the system, but I think this is positive long term. It can also make testing harder, and the reason is because from the high-level kind of black box testing perspective, there's more different permutations and combinations you might have to test. Right? So while you can test individual components in a clean fashion, if you want to test an entire kind of architecture top to bottom, a whole stack, you may have to have some very complex DevOps to do those tests. And there's a risk that if we don't get the APIs right between these interfaces, we may get locked into really crappy APIs. So let's not do that. All right. In the final couple minutes, I want to speak a little bit, as I promised, to what this means for application developers. So point number one, I have 3 points. Point number one, it's going to get worse before it gets better. Okay? If you build an application today, a Web3 application, a dApp, whatever, there aren't that many choices you have to make. Assuming you're using Ethereum out of the box, right? You're using Solidity, you're using maybe Hard Hat, you're using Infuria, Truffle. There's a relatively small set of tools, and there's not that many options. You use Web3.js, you fire off a transaction, you wait till you get an event back, you know that the transaction was confirmed. In a modular blockchain world, this is going to get really, really wacky for a while. Finality is not super well defined, right? You're going to have a lot of asynchronous calls. You can do things in a somewhat synchronous fashion in the current world, in the monolithic world, but that will no longer be possible in a more complex modular world. You're going to be having things moving across different kind of infrastructure boundaries, et cetera, et cetera. Also, you're going to have to think more carefully about your kind of application and data model, right? Like, you may have different classes of data in your application, and you may need to figure out, okay, this data is consensus critical, this data is not consensus critical, this data can live in browser storage or on AWS or some centralized thing or something, but like this other piece of data, we need to sort of home in on it, and that needs to go into a consensus data availability layer, things like that. So these are all positive trends, but it's going to be challenging. It's going to be bumpy in the beginning. You saw this slide earlier. These are these JavaScript frameworks. We really desperately need these frameworks in Web3. And the beautiful thing, as I said, in the JavaScript Web 2 world, is that these frameworks hide away all the complexity under the hood. So the application developer, again, can just focus on building the best experience possible, and they don't need to worry about things like finality and async and this and that. So these don't really exist. They're kind of just beginning to emerge, but I'm very bullish on these, and if you're interested in working on these, please come talk to me. Finally, the good news, point 3, once we get over some of these initial hiccups, things are going to get much, much, much faster. We are moving into a world, we're moving from a world of a handful or maybe a couple dozen transactions per second, maybe on the order of hundreds or thousands in the case of blockchains like Solana, into a future where we're going to have hundreds of thousands or millions of transactions per second, right? And that opens up entire application use cases that were never possible before. Gaming is a great example. So I really believe that we're moving into a future, thanks to the modular blockchain architecture, where applications are going to look and feel much more familiar and much more like the kind of applications we're used to before. That is all I've got. So these are 3 resources I want to leave you with. These are the places I learned about modular blockchain. So Starkware, many of you probably know this project. They have a lot of great resources out there on this idea. They're a big roll-up platform. There's a blog, polinia.medium.com. Really, really excellent work there. Lots of amazing links. You can spend hours going down that rabbit hole. Check it out. And I mentioned the project Celestia. They also have a lot of great documentation on their blog. That's it. My Twitter is Rettig. My DMs are open. If this stuff is interesting, hit me up. I'd love to chat. And let's roll up our sleeves and get back to work and start building the tools we need. Thank you.